Ooh, more optimization. Again, we're going to optimize a distance formula. Okay, so let me write out the distance formula. You subtract x's, square it, subtract y's, square it, and you add them, then square root it. That's going to be your distance formula. But remember, we want to write the distance formula in terms of x or in terms of y. That means we don't want to have two different variables. We want to have only x's or we want to have only y's. And so when we think about this problem, there's your y1, there's your y2. Now, it doesn't matter which one's your y1, y2. It just matters that, we're not going to write any more y's. We're only going to write x's. Now, in this case, the x1 and x2 are the same. And so when we plug everything into our distance formula, it actually cleans up quite nicely. Because we have x minus x and those x's are the same, this goes away, which is great. So now we have the distance formula written in terms of x, and then we also see that this square root cancels out with that squared. Nice. So we have to find the derivative of that distance formula, which is just going to be cosine 2x. The derivative of sine is cosine 2x, and the derivative of negative 2 cosine x is going to be, oh, and don't forget, it's a chain rule because there's a 2x on the inside of the sine 2x. And then the derivative of cosine is going to make it a positive, but now it's a sine. The derivative of cosine is negative sine. And so this is our derivative. And what we have to do is we have to find our critical value. So we're going to set this guy equal to 0 and try to solve. It'd be easier to solve this if both of the trig functions were the same. And so I see that this is 2x right here. And I can rewrite. That means I can use a double angle formula. I can rewrite cosine 2x to be 1 minus 2 sine squared x, which is nicer because now I have only sines. And when I simplify that a little bit, I get 2 minus 4 sine squared x plus 2 sine x. And if I put it in standard form-ish, sine squared, sine, and then no sine, this is what I got. So it looks like we got a trinomial function here that we have to factor in order to solve. And so I'm going to divide both sides by negative 2. And this is what I have now. I have 0 equals 2 sine squared x minus sine x minus 1. I'm going to factor by going 2 times negative 1 to give me the negative 2. And I'm looking for two numbers that multiply to give me negative 2 and then add to give me negative 1. And I get 1 and negative 2. And so I'm going to rewrite this middle term right here using the 1 and the negative 2. So I have 2 sine squared x, positive 1 sine x, and then we have our minus 2 sine x. That's what we do with those. And once we do that, we can use grouping. I'm going to group the first two terms and the last two terms and factor. I take out a greatest common factor from the first group. I can take out a sine x, and then from the second group, I can take out a negative 1. And now we have 2 sine x plus 1 in common here, so we can factor that guy out. So I have 2 sine x plus 1, and then we're left with sine x minus 1. So we take each of those factors and set it equal to 0. We're going to get sine equals negative 1/2, and sine x equals 1. Trigonometry. Okay, so let me do a little bit of refreshing for you guys. We are in an interval, so our x's have to be between negative 1, negative pi over 2, and pi over 4. I'm going to throw this on a unit circle so you guys can hopefully remember some of this stuff. Our angle has to be between these two angles, negative pi over 2 and pi over 4. Now, when I solve this first one, sine x equals negative 1/2, I get negative pi over 6. That's where the y value will equal negative 1/2. And then for the other one, the only place where sine equals 1 is at pi over 2, which is outside of our domain, our two angles here. And so we only have to test negative pi over 6. Now we're trying to find the maximum vertical distance. And so what we're hoping for is that we're going to get a positive minus. That's what maximum means. It means positive minus on the sine line graph. And so I'm going to have to pick two tester points. I pick easy tester points so that I can plug it in easily. I pick 0. And when I plug 0 in, and now what you're going to want to do is you're going to want to go back here and plug 0 into this. But there's a problem. And the problem is we divided by negative in order to get here. Because we divided by negative, we changed it. And we need to change it back. If you guys remember, we had a negative 4 sine squared x plus 2 sine x plus 2. And we have this negative out in front. And so we're going to have to put a negative on this guy so that we get the appropriate sign. We get the correct sign. So when I plug 0 into that, let's see, if I plug 0 into this, that would be sine of 0 is 0. 0 times 2 is 0, and plus 1. So we get a positive right here. And over here, we're going to get a negative. So we have a negative times a negative, which is a positive. So we can say positive for right there. Now for the negative power of 4, I'm going to write this one out. If I plug in negative power of 4, sine of negative power of 4 is going to be negative rad 2 over 2. So this will be negative rad 2 over 2. Times 2 would be a negative rad 2. So let's put negative rad 2 right there. And then we have our plus 1. And then over here I put, this is negative rad 2 over 2, then minus 1. This one is going to be a negative. That's because I know the square root of 2 is like 1.4 or something. So that would be a negative 1.4 plus positive 1. That would be a negative. And over here we have a negative minus a number, so that's also going to be negative. So we have a negative times a negative times a negative, which is a negative. So we have the x value that gives us a maximum vertical distance. Just so for funsies, I graphed it for you guys to show you. This between this point and this point, when x is negative pi over 6, we have our maximum vertical distance between these two functions.